In this video, we'll look at one quick example and to demonstrate how those concepts can be related. Those concepts are density, specific volume, specific gravity, and specific weight. So let's see. If our problem is given this, given our specific gravity is 1.2, then we need to find the density, specific volume, and specific weight. Okay, so how do we solve it? We start with specific gravity. Feel free to get ahead with me. Specific gravity is density of this material over density of water. We already know that's going to be 1000 kilogram per meter cube, and the density of this material is what we are solving. The specific gravity is 1.2. That's unitinous. So from that, we can find our density, which is 1200 kilogram per meter cube. So we finish our first one. Then we need to find our specific volume. Specific volume is 1 over density, right? And then it's 1 over 1200. And that will give us the unit of meter cube per kilogram. Put into calculator. That will give us about 8.3 times 10 to the negative 3 meter cube per kilogram. Alright, so the last one we need to solve is specific weight. Specific weight, from the previous video, we said there are a couple of expressions. Original one is weight over volume, but another expression comes quite handy sometimes. For example, here, it's rho times g, right? So in order to find the specific weight, as long as we know the density, we can find it. We already know our density is 1200 kilogram meter cube, and our g, it's use 9.8 meter per second square. Okay, then let's put our numbers in there. We will get an answer. 1200 times 9.8. That's the answer is 11,760. But here I want you to focus on the unit, okay? When you look at this unit, you will get kilogram on the top and this meter, and that cancel out. We'll have meter square per second square, and that is some kind of cumbersome unit, right? Because we do know, one thing we do know, specific weight have another expression as weight over volume. And because of that, we know the US unit that will give us weight is Newton over meter cube. That should be the unit. So my question is this unit same as this unit? They should be, right? Then we'll have to kind of prove it though. Why they are equal? So let's start with kilogram meter square per second square. Now let's thinking about what's Newton. Newton is the force unit. Force equal to ma, Newton's second law, right? Force is equal to mass times acceleration. So Newton is equal to kilogram per meter times meter per second square. All right. So do we? So it's actually easier for me without canceling it. So I'm actually gonna go back to its original. So kilogram meter cube, then meter per second square. Now let's look at it. Kilogram meter per second square, that's our Newton. So it's Newton per meter cube. You just proved it. This unit, it is the same as Newton per meter cube. So that's it for this video, and we did a quick example on given one property, and you can find the other three. And you can do this by yourself, try to give another property such as specific volume. And then can you find the rest of 3? Okay? All right. I'll see you at the next one. Bye now.